Okay, this is how far 3, number 1. This is a problem just to practice free fall kinematics here. So we got Helen wheels. Yes, thank you. All right, launches a rocket in the air for a total of 7.48 seconds. So that means it goes up. Look how straight a line I can draw, and it goes down. And we're assuming that there's no air friction. And so what's going to happen here is that it's going to spend the same amount of time going up as it does going down, because I guess we'll assume it hits the ground at the same elevation it's launched from, right? So the first question is, what time does it spend going up? Well, it's going to spend half the time up, right? And half the time going down. So the answer to that is 7.48. And this is what you always do. If somebody tells you that it's in the air for a certain amount of time, this is the simplest thing to do, is just cut that guy in half. Okay? So 7.48 divided by 2 is reliably 3.74 seconds, right? So that's this guy. So it's 3.74 seconds up, 3.74 seconds down. Okay. Let's see, what's its initial velocity? What's its final velocity? Well, whatever it's got for the initial velocity, right? Okay. Whatever that is, it's going to be positive here, and then its final velocity, when we talk about this 7.48 seconds, right? The final velocity will be negative whatever this one is. So if this is, say, 20, this will be negative 20. If that's 30, this will be negative 30. Okay, so that's the rule of whatever goes up comes down, but it comes down at the same speed if it's the same elevation, right? So what I'm going to do is I'm going to go from the ground to the top. Okay, so let's just set this up. We're going to go S, U, V, A, T. Now, whenever we're in free fall, we know that this is negative 9.81. Okay. And then we know that the final velocity at the top is 0, because if it's not 0, it's not at the top, is it? Okay, and then we know the time is 3.74 seconds. Okay, so to figure out the, let's figure out S and U, okay? Let's figure out the U first. So V is U plus AT, and now we're set. So 0 equals U plus negative 9.81 times 3.74. Okay, so let's just try that. So U is actually going to be positive, this thing. So I'm going to go 9.81 times 3.74, because you would add this to this, or subtract it, add it to both sides and get it on this side positive, right? So that's 36.6894. 36.6894. Okay, meters per second. So 36.7 is entirely reasonable. Okay, and then it says how high does it go? Right now, the problem is, do we have a formula that can do that? We don't have a no U. Remember this? We don't have a formula for no U. So to figure out the displacement, right? So what's its initial velocity? The initial velocity is positive 36.7 meters per second, right? Okay, so that's its velocity leaving the ground, right? 36.7. It's positive, right? When it hits the ground again, it's going to be negative 36.7, okay? That's because it's going down. Here it's going up, okay? And this is ignoring air friction, of course. All right, let's see. So the final velocity, we're good on that. We've got its initial velocity, right? How high did it go? Let's do that, and then I think I'll do this in the next video. Okay, so now let's figure out how high. Oops, failure to draw a horizontal line. Okay, so to figure out how high, we now have to actually use that formula, because we don't have a formula that has no U. Okay, so what do I use? I think I'm going to use this guy. S equals U plus V over 2. There's a lot of them. By the way, I could use any one that has S in it, but this one's pretty simple, right? So let's pop this guy out, right? Okay, so this is still ground to the top, right? Ground to the top. The initial velocity is 36. Notice I'm not using 36.7. I'm going to use my unrounded version here. 9, 4, right? And then plus the final velocity is 0. Okay. Then we're going to divide by 2 and multiply by 3.74. My pen goes slower and slower. I don't know what's up with this MacBook Air. Okay, so now if I plug that into the calculator, divide this guy by 2 and multiply by 3.74, and I get the height to be 60.609. 68.609. Okay, so I get this actually to be 6. Okay. Six meters high is how high it goes. Okay, so to answer these questions, I'm going to do this in a separate video. To answer these questions, time spent going up is half that time, 3.74. Initial velocity is positive 36.7. Final velocity for this time, right? Notice we split the time in half to solve other things, but for that time, the final velocity is negative 36.7. Right, so that's the sense that that question is being asked for. How high did it go? Well, again, we used ground to the top. It went 68.6 meters, right? Okay, and then what is its velocity at 50 meters? We'll do that in the next video, and what we'll do is we'll use this number here, okay? So just remember that number. We'll just use that, okay?